Hello, welcome to the Industrial Arts Institute. Today we're going to go over shielded metal arc electrodes, mainly the numbering system. There seems to be a lot of confusion with people, and I'll try to make this simple for you. Some of the confusion, I get it myself, is the way they describe electrodes anymore. Now we talk about what the coatings are in the flux makeup, not necessarily the characteristics of the coating. Nowadays it's cellulosic or rudile, what's that mean? I don't know. It's just what they make the stuff out of. Makes no sense to me. I'd rather talk about how that affects the welding with that electrode. So we'll go over that and also over the numbers. I'll start going over these numbers a little bit, break it down for you. The first two numbers, and in some cases the first three numbers, and in some cases the alloy count. All of these here, other than the stainless one, is the tensile strength of the electrode, okay? So 60, 60, 10, 70, 24, 70, 70, 18, 70, and then 110, 18. That is the tensile strength. What tensile strength is if I had 1 inch square bar, it's how much it takes to pull that in two. These are minimum tensile, so those electrodes should pull more than that. And that's all you need to know really about the first ones. Whatever material you're welding, metal-wise, you should always have your electrode match or be stronger than your base metal. Pretty simple. And 60 is probably going to take care of that for you. The third digit here, and you'll see it's always ones or two, is the position I can run that electrode in. One would mean all position, flat, vertical, overhead, horizontal. I can do whatever I want for the most part with that electrode. Two would mean flat only. That would be a flat only groove, a flat fillet, and a horizontal fillet, which is a T-joint by most people's standards. I could do those three with that. I couldn't do any other position. It's too much high deposit rate. I have to stick with the flat positions only. There's also a 3 and a 4 in this position, and I've never seen them in 34 years of welding. But they do exist, so I'll let you know about it, but good luck finding them because I ain't never seen them. The most important part, the part I want to talk about today, is the last digit. This has everything to do with the characteristics of the coating, okay? So we'll start at the top, 0, 60, 10, and also 60, 11. These two electrodes are a fast freeze type characteristic. What that means is I'll come in, I like the electrode, I'll come in and plant it, and deposit, and I'll step out, let that solidify. Then I'll come back in right in front of that a little bit and make another deposit and step out and let that solidify. And what that does is gives me that dime on dime type appearance. Very good for welding rusty metal, galvanized metal, dirty metal, painted metal. Also helps with penetration for open root type pipe welding. The negative side is low deposit rate and not such a smooth bead appearance, depending how smooth the operator is. But it's never going to look as good as other type of rods. On the other end of the spectrum, we're going to skip down to the next type, will be the fast fill type, the ones that have the 2 in the all position or the position. These electrodes have, and here's one here, big fatty, 7024, prime example. They have a lot of iron powder in the flux makeup. So I get the deposit of the wire electrode, but I also get deposit of the iron powder. Iron powder also does other things too. It gives me a more fluid puddle, which gives me a much better bead appearance. This type of electrode, I don't do any kind of manipulating. I have maybe a bit more drag angle, and I just start it and let it cruise. Easiest electrode to run. Don't let the big fatty spool you. This is the easy one here. So that's total opposite of the spectrum than the fast freeze type. This one freezes so I can manipulate, and this one fills a lot, okay? Then there's electrodes that have a blend of both of those characteristics. 6012, 6013, actually all these 7016, 7018, on and on. Those are a blend of them, and they call them a fill freeze type electrode. Those I can manipulate in and out in my puddle, but I don't step out of the puddle and come back into it like I would with a fast freeze electrode, but I still manipulate, take control of the puddle. These here type, 6012, 6013, and probably 7014 for that matter, you don't see much action anymore. The gas metal arc wire welding process have taken a lot of their action. They were pretty big in the old days before that. Very good for thin material. And the other thing they work very well on anymore is training. We use them a lot at the school They're easy to light, easy to run. Guys that have AC welders at home, they like them too for the same reason. So farmers and students probably use these more than anybody else anymore. A hybrid, the hybrid of those is the low hydrogen types, 7018, any stainless type electrode. 5, 6, or 8, that means you got a low hydrogen electrode. What that is the flux makeup is different. 7018, low hydrogen electrode. They have primarily a limestone base electrode. They don't have the wood pulp like those other ones have that require moisture. Moisture is your enemy welding. Moisture leads to hydrogen cracking. Hydrogen cracking is not when you're going to see on the surface. You're not going to weld with this type of electrode and then look at it and see cracks. Not where they're at. They're in the underbed. The thicker the material, the more likely you would have this issue. You could counter hydrogen cracking by preheat. And the best thing is using the proper electrode. These type electrodes, all of these low hydrogen, 15, 16, and 18, should always be kept in a sealed container away from moisture, or better yet in a rod oven at 250 degrees or more. Where I work now, majority of stuff we weld most anywhere. You go to a power plant, shipyard, I cannot use any of these electrodes other than low hydrogen. They're that concerned about cracking. 7018 being the most common electrode anymore. The other thing, when I qualify, if I qualify with 7018, it covers all these other electrodes. So the last video when we showed qualifying, why were we using 7018? It would cover me for 6010, 6013, and all the other electrodes. So that's why thoroughbred of welding anymore, 7018 in the SMAW world. In the last video we did, we qualified in the 3G position with flux core and 7018. And I'd like to explain what that would cover as far as welding positions and weld types. So I'll start with the weld types. Okay, there's 2 types of welds, for those that don't know. There's groove welds, which are basically joining 2 pieces of material in the same direction. And then there's fillet welds, where they're perpendicular. Okay, in the groove weld, a groove weld, by qualification, the ones we are doing, are full penetration, meaning the weld covers the full thickness of the base metal. Okay. A fillet weld, on the other hand, is not a full penetration weld. You can see here, if I get decent penetration on a fillet weld, I still have this void in the middle. Okay, so this is why when you qualify in a groove weld, this would cover me for this. Okay, so groove welds cover fillet welds. It's that simple. A lot more work in groove welds. If I go over here, this says butt joints, same thing as groove welds. You can see there's numerous kinds. There's kinds I have, like we've been qualifying with backing. And there's also double welds where I weld from both sides of the material. If I qualify with backing, that will cover me for welding from joints with weld from both sides. This is a double weld. They refer to this as double weld, where I weld this side and this side. Groove welds with backing qualify double welds. Okay, it's that simple. So that's why most of the time we qualify in groove welds, because that'll cover the fillet welds, and it'll also cover partial joint penetration groove welds, which I don't have an example here for you. Now we'll talk about weld positions. Okay, we'll do grooves first. Okay, if I'm flat, flat would be a 1. Okay, and 1G, G would be groove. Okay, so it's kind of simple lingo. Horizontal, which makes sense. Groove weld would be a 2G. Vertical would be a 3G, and overhead would be a 4G. Pretty simple. If I go to fillet welds, the one that tricks up most people is the 1F. The 1F is actually not a T-joint on the table, as most people think. It's actually a 45V groove, which I like to run 7024, and electrodes that have high deposit, metal core, spray, GMAW. They work really well in a 1F position, although most of the time you're doing 2Fs. The 2F is a horizontal, a typical T-joint by most people's standards, and then the vertical is the 3F, and then the 4F is overhead. So we did last time. We qualified in 3G, just like that. Groove welds cover fillet welds. So if I do a 3, that'll cover me for 1, 2, and 3, not overhead, not 4. It'll also cover me for 1, 2, and 3 in the F positions. So by doing one qualification with groove weld with 3/8 plate, I'm good for all 6 of these positions. Okay. If I want all positions, then by AWS D11 code, I would have to do a overhead, a 4G, and that would give me the 4G, the groove, and it would also give me the fillet weld. So by D1 steel, those two would give me all positions. So groove welds cover fillet welds, okay? So if I do a 1G, and probably the only reason I do a 1G is the process I'm welding has to be welded flat. A 1G would cover me for a 1F, a flat fillet, and a horizontal fillet. So this qualification would give me this one, that one, and this one, okay? If I did a 2G, 2G would cover a 1G, and it would cover them as well. So not a whole lot of gain by just doing a 1G. Although I will tell you the 1G is probably the hardest joint to weld. I have the most trouble with ultrasound testing with 1Gs. I get a lot more slag entrapment and lack of fusion. But moving on, 3G, if I do a 3G like we did in the last video, that'll cover the 2G, which is probably harder, and a 1G, and also the 1F, 2F, 3F. Won't cover 4G. If I do a 4G, here's where it gets slightly tricky. A 4G won't cover a 3G, but it'll cover a 2G, a 1G, and the corresponding fillet welds, 1, 2, and 4, not 3. So if you want all position plate qualification, which most companies do, iron workers, boilermakers, millwrights, that type of tradesmen, you need to do a 3G and a 4G. That will cover everything on that poster. So this is AWS D11 code 2015. Got to always have the latest and greatest one. A big deal with everybody. I got these last 15, 20 years laying around. Here are the F numbers for that. The F numbers haven't changed. 20 years I've been looking at these. They're no different. Here's an example of F numbers. Shielded metal arc electrodes are classified in F numbers. F number 1, which would be like 7024, they only show you the last 2 digits. They don't care about tensile. That would be the most common one we talk about is 7024. It'd be an F1. That's a flat only electrode. You'll notice all of these F1 electrodes are all only flat position. The next one up is F2, would be like a 6012, 6013, 7014. And you'll notice they're also going in the way, the most difficult, from the simplest to the most difficult. F3 would be like 6010, 6011, 7010, those type electrodes. And then there's F4 on top, which is the low hydrogen. Note the 15, 16, 18 thing again. If I qualify with 7018, for example, the most common low hydrogen electrode out there, which is all these are low hydrogen, that F4 designation covers F3, F2, and F1. So everybody, why do I qualify with 7018? Because if I qualify with 7018, that will cover me for 6010, 6012, 6013, 7014, and 7024, the most common other electrodes that seem to be in use today. So that's why everybody qualifies with the low hydrogen 7018. By the way, it's probably a little more difficult than the other ones to qualify with. So the other thing as far as welder qualification, welder being the person, welder performance essential variables, things that would make you not qualified to weld something. Now I'm going to read these to you. A process not qualified, GMAW short circuit. I haven't talked about wire welding, but short circuit, D11 code, not a big fan of it. If anybody's qualifying you in thick material, especially uphill, with short circuit GMAW process, they're wasting your time. You shouldn't even be doing that. We'll go on to the next one, an F number to a SMAW electrode with an F number higher than the one you qualified to, which we just talked about. So if you do a F4, I'm covered for all the other ones. If I qualify with 6010, I can't do 7018, and that's what they're saying. To a position not qualified. So in the first video we did, we welded in a vertical position. That would cover the horizontal, the 2G, and the 1G, and Fs that go with that, but it wouldn't cover me for overhead. That's what that's saying. This pertains to pipe to a diameter or thickness not qualified. We're not talking about pipe today. The number 5, to a vertical welding progression not qualified, meaning if I welded uphill, I'm not qualified to weld downhill. This would not apply to 7018, which is an uphill only electrode. This would be maybe in the case of 6010 welding pipe. So that don't pertain to us either because we're not talking about pipe right now. Here's one that does, omission of backing. If you qualify with 3/8 groove weld in a 3G position with a backing bar like we did, that does not allow you to weld open rut. Okay, you can double weld, meaning I can weld both sides of the material, but I am not qualified to open rut, meaning I weld the whole thing from one side like a pipe. That would not cover you for that. And then the next one's multiple electrodes. What I'm pointing out here is you didn't hear one thing about weld strength, meaning say a A514 that has 110 tensile. Am I qualified to weld that if I qualify an A36 material, which is only 60 thousandths? I absolutely am qualified as far as the welder goes. I would need a weld procedure for that higher strength material and perhaps a PQR to go with that. But as far as the welder, if I qualify with 7018, I am qualified to run 11018 as well. So all this stuff, those are the things that you cannot do, and increase in tensile strength does not apply. 6010. 6010 is an electrode designed to be whip manipulated. I'm not going to drag this electrode along like I would 7018, 6013, those types. By whipping it in and out, gives me a lot of control of it, especially out of position. I can do anything from weld open rut to weld thin material with it. It also is good at burning through paint, galvanized, rust, whatever. Very universal type electrode. Negative side, not a very pretty bead appearance, and not a lot of weld deposit. So I'll fire it up here in a minute. Gotta change my hood. Come in, I'm going to light the electrode. I'm going to have deposit like a tack. Then I'm going to step forward, let that solidify. Then I'm going to come in and put another one right in front of that, 1/16 to an 1/8 inch. And the concept is kind of like a roll of dimes. I should have a dime on a dime on a dime every deposit. That gives me the ability to weld out of position, open rut, dirty stuff, thin stuff, very universal. Here we go. Ready? I have to brush that off. See, that gives me that look right there. Every one of those steps is one of them ripples. I come forward, I come back, and I make that deposit, and I step forward. So that gives me that dime on dime appearance. And that's basically how that electrode is designed to run. Okay? It's not maybe as pretty as some other ones, but it has its own advantages. Another advantage of 6010, the fast freeze type electrode, that whipping action allows me to weld thinner material. I'll give you a demo of that right now. Here we go. .6010 fast freeze electrode, weld thin material. The whipping action allows me to step out of the puddle, let it cool down, and then come back into it. Like I say, that's good for cleaning rusty metal, galvanized, paint, works for everything. Bad side, not a real pretty bead appearance, but it's not what it's about. That's fast freeze, okay? Now we're going to do fast fill. This is an electrode designed to deposit a large amount of metal. Advantages, pretty appearance, high deposit rate. Disadvantage, can't weld out of position. Everything got to be flat. It prefers a 1F flat fillet versus a horizontal fillet, or T-joint as most people refer to it. I'm going to burn the big fat rods because, well, they're cooler than the little ones, and you get a lot more deposit. Big rod, no trouble. Actually a lot easier than some of the smaller ones. And this time I'm going to put it in, and I'm just going to leave it a fairly decent drag angle and just cruise with it. There won't be no arc manipulating in and out of the puddle, none of that. Just plant it and run. Here we go. see, nice bead appearance, easy to run. If you had something that required a lot of deposit, don't need low hydrogen, flat position only, 70-24, hard to beat it. Fast fill. So far, we went over fast freeze electrode, 60-10, 60-11, that type where I have the whipping action. Welding dirty stuff, thin stuff, whatever. And then on the other end of the spectrum, we have the fast fill, 74 type electrode, 70-28 if you need low hydrogen, where I can put a lot of deposit down, pretty bead, no manipulating, but I can only weld flat with it. Two totally opposite type electrodes, okay? Now there's a blend of those two, which is the most common one that they call fill freeze. Those electrodes, 60-12, 60-13, 70-14, and 70-18. So you have both characteristics. Those ones I move around in the puddle, but I don't leave the puddle, okay? So, yeah, I'll give you an example. Ready? 60-13 fill freeze type electrode. Here we go. (60-13). That'd be the fill freeze electrode. Not much use in the market anymore for 60-13. More so probably in training and welding schools. Sometimes farmers, guys at home in their garage maybe, especially an AC polarity welder. But anymore, not much use. The wire welding process has taken pretty much all its thunder. Kind of an old school thing in the past. Good for training though.